Algebra 2, new chapter 4.1, we're getting into inequalities. That means that we need to review two very important symbols. The first one, this arrow that appears to be pointing towards the right, it's really an inequality symbol. It would be read is greater than. This symbol, this arrow pointing towards the left, would mean is less than. And we're getting into some problems today. 4.1a, look at our learning target, our first one. I can translate a statement into an inequality. 10 is greater than, well, we're just going to write 10 greater than C. X is less than or equal to, well, this means write the less than, but put a bar underneath. Is less than is just that arrow pointing towards the left, but when it says or equal to, we've got the bar below it. 6 is less than y. Well, the less than symbol looks like that. And really, we're done with our first type of problem. Our second learning target, I can graph an inequality on a number line. Please understand that when you do not have the equal bar under that inequality, that will be an open circle. This is read x is greater than 6. And what that really means is we can be larger, or than negative 6, I should say. So we're going to put an open circle. I'm going to put it above the number line so it really jumps out. I cannot equal negative 6. That means without the equal bar, it's an open circle. Greater than, when x is on that left side and x is greater than, you want x to be larger. So the arrow points to the right, you shade towards the right. That's only going to be a little mnemonic when x is on the left side, or the variable is on the left side. This could be read as d is less than or equal to 4. So as we work this out, we realize that we can equal the 4. That means we'll have a closed circle above that. If d is less than, it actually means that we want numbers that are smaller, and we would shade towards the left. And that's it. By way of comparison, we can work in reverse. Look at this learning target. I can write an inequality for a given number line graph. You can see we have an open circle above negative 1. There's no equal bar. So an open circle means no equal bar. But you can see we're pointing, we're graphing off to the left. That means we're smaller than negative 1. We can say x is less than negative 1. Looking at number 5, when we have a closed circle, that means, of course, we're going to have an equal bar. That means we're allowed to equal the 2 here. We're going to say x. And you can see that we're shading towards the right. We're going to make our arrow point towards the right. We'll put a little bar underneath that and plain and simply say x is greater than or equal to 2. Well, we've been dealing with inequalities, but we can deal with compound inequalities. And compound just means that we're getting more than one at a time. So we've got our first scenario. The word and is what's really happening here. If we're told that x is greater than or equal to a small number, and that's that operative word, and x is less than a big number. Now, by the way, there's another way that we could write this. We could say that the small number is actually less than or equal to x. I'm sure you remember in elementary school you learned about the mouth of an inequality always opening up towards the larger number. The mouth, like an alligator or a Pac-Man, is opening up towards x. Similarly, we could also flip this around. We could say the big number is greater than x. In this regard, the mouth is opening up towards here, regardless of how you write this, what you ultimately will do for an AND problem, and please hear this, this is the most important thing, is you're always going to put the small number on the left, the big number on the right, arrows pointing towards the left, and X in the middle. If you've got a small number on a number line, and you've got a big number on the number line as well, what that really means is you're going to be between them. You're going to be between them. And that's what an AND statement is all about. It's saying you want all the numbers between the small number and the big number. Remember that. The AND graph looks like a little stick. Small number on the left, big number on the right. Look, you still have it even on the number line. Small number on the left, big number on the right. By way of comparison, we could have the word or. Or is not joined into one picture looking like a little stick. We're going to say X less than small. Now, we could also have written that by flipping this. The mouth of the inequality is opening up towards the small. So an equivalent form would be this. The small number is bigger than X. Or we could say the big number comes on the left here, and then the mouth of the inequality has to open up towards X. You know, as you look at this, what's the big realization that you have? You've got the word or. Now, the word or is never joined into one inequality. What you're always going to have is X is less than the small number, or X is greater than the bigger number. That's the way you have to write it. Now, visually, it's going to look like this. You're always going to go in separate directions. You're going to be smaller than the small number, so you go, to the left of it. You're actually going to get bigger than this larger number. You're going to go to the right. Never shade in between. With the word or, you're going to shoot outside. So let's see if we can real quickly get this worked out. It says, I can write and graph an inequality for a compound written expression. -3 is less than X, and, here we go, it's that and. We have a joined inequality right now. We know that 5 is greater than or equal to X. You know what you've got? You've got your small number over here. You got your big number over here. And the small number, of course, is going to be -3. The big number you can see in the problem is a 5. You put X in the middle. This connection with X involves no equal bar. -3 is less than X. And that's literally the way we write it. It says 5 is greater than or equal to X. You would think, wow, that's not what you're writing. If there's an equal bar in this part, so I'm going to write it with that equal bar right there. What troubles kids sometimes is they'll say, you didn't write 5 is greater than X. Wouldn't that be 5 greater than or equal to X, just like this? Yes, but look, the mouth of the inequality is opening up towards the 5. It's opening it up towards the 5 here. It is equivalent. This would be the inequality that you'd write. -3, we have an open circle, no equal bar. 5, we close it up, and then we just connect in between. That's an AND graph. AND graphs always look like a little stick. For the next problem, really our last problem here, we've got the word or. And guys, the or problems, you're not going to be able to join together. They're always separate. X is less than -2. Well, you just write it like that. Or X is greater than 4. You have to recopy the word or. X is greater than 4. What would it look like visually? Well, open circle above the -2. X is less than that, so you're going to go in that direction. X is greater than 4, so put an open circle there. Greater means go off to the right. Never shade in between for an or problem. you just go in opposite directions. Now I do, of course, want to show you some things about ALEX. When you go to ALEX, as we read this, 4 is greater than or equal to x, the way you have to type it out, look at these 4 boxes here. Greater than is going to be, the arrow pointing to the right, but we need the equal to. We'd have to put this down here and then type in 4 greater than or equal to, type your x, and then you can move on. As we take a look at some other things here, take a look at the graph. Y greater than or equal to 4. The bar means you're going to be able to have a closed circle. So go to the closed circle. You have to go on the number line rather than going above it. Greater than really means that we're going to shade towards the right. Greater than always means that and the arrow is pointing towards the right, and we go this way. Right here, all you gotta do is just click that bar to officially darken it in, and then you just hit the right arrow and keep going. Right and inequality. Well, you're going to have your choices. I think you can see here we're going to have a less than. Hopefully you're getting the idea. Because of the equal bar, we're going to need that. We can say x is less than or equal to -5. And then, of course, you're also going to have compound inequalities. You might wonder how you do that. The word and indicates that you've got a joined inequality. W is greater than 1 and it's less than 6. Well, always have your arrows point towards the left. Small number on the left, x in the middle. So just type in x right there. Oh, W. They're asking us to use W. Sorry about that. But your next arrows have to point towards the left as well. The and always has that. So you're going to have to click this twice. Big number on the right. They never asked for us to have an equal bar. But that's pretty much all I wanted to show you for today. Hopefully that's enough to get you started in navigating through ALEX.